the PLC is able to control that to be able to turn on the smells, as well as they have these pokers. So they have these pokers in the seats to make you feel like you feel this little pinch or something like that.
Hi, this is Terry Person. I'm with Entertainment Engineering. This is our one-on-one with design engineers. Today I'm talking with Michael Cuaresma.
Yeah.
He's a mechatronics applications engineer with Festo and is going to talk with us a little bit today. I'd like to start a little loosely because I think it's important that people understand who engineers are from the beginning and not just what they do. Just quickly, what got you into engineering in the first place? I mean, how old were you? Do you remember how old you were when you first thought, this is what I want to do?
Yeah, actually. So it was probably either my junior or senior year of high school, actually, when I first understood what engineering really was. I mean, took some uh took some science classes, took some physics classes, so kind of understood a little bit about the science and the backgrounds of it. But then um I've always had a knack for trying to fix things. And in particular, there was a play I actually had a PlayStation 2. Um and it kept breaking on me. And so then I was like, well, how do I fix this? And then that's when I realized that I can take these screws out. I can kind of get into like the board. I can, what I ended up finding out was that the lens was dirty. So I go in there, clean the lens, put everything back together where I remember I think everything is supposed to go. Obviously, a couple of screws are still left behind because I forgot where to put those screws, as any high school person would realize.
Yep.
Um, and then I turned it back on and it worked. And I was like, whoa, that's actually kind of cool. Like I was able to really fix that and go from there. So that kind of sparked my interest in electrical engineering in a sense. Um, so then I kind of thought, okay, maybe I'll start doing like microprocessor like design work and so that because that's what kind of goes into like Sony. So Sony actually was one of my dream jobs at first, like to work on like the next PlayStation or like something cool like that, or like a camera or like a DSLR or something. So I was like, oh, okay, that sounds like a cool like to design. And then I remember going into college, getting accepted to go to Cal Poly Pomona for electrical engineering, and I was like, okay, this is great. This kind of helps me lead into what I wanted to do. Um, but then I remember taking a controls class, and in that controls class, being able to essentially program design and seeing everything work in the controls platform, and I realized that's what I really wanted to do. And so, um, living in Anaheim or living up in Orange County at the time, and one thing that also really fascinated me was roller coasters like engineering or for like theme parks and stuff like that too. So, the whole that idea of like controlling for like roller coasters, theme parks, as well as the class of controls engineering kind of set me in this path of, okay, I think this is something that I think I want to do. And that's kind of how I pursued it. And I got lucky that I ended up getting an internship at a controls engineering firm, which I didn't know at the time. And so then they were able to kind of guide me into, okay, this is what we do here, and this is what it is. This is what a PLC is. I had no idea what a PLC was at the time. Um, and that's kind of where it just bred into this whole like, okay, I can do this now and I can do this now. So working there, being an application engineer, what I love about that is that I get to have my hand in so many different industries. So I still work with the entertainment industry, which is kind of how we're here today,
Yeah.
but I can also work in uh, food and packaging, or I can work with the semiconductor industry, and I can work with medical. And so all of that really helps me not stay stagnant. I think that's what I really enjoy about it.
This is what we find as well. We find that, and we focus a lot on what we call tech transfer. So, going from one technology, one industry to another industry
Mhm.
with the same technologies, which is just what you're saying, and which is why we started entertainment engineering anyways, because the entertainment side is kind of the hook, it's like,
Yep.
oh, that's cool. But then everything we talk about can be used everywhere else.
Yep.
And so this kind of drives right into the project that you were on that maybe we'll talk about for a few minutes.
Hmm.
And that was with Mediumation.
Yep. That's correct.
Okay. And that project I thought was really kind of cool that you took seating and you uh, matched the seating to a film,
Yes.
basically. And so, can you talk a few minutes just about what part of that was something that you helped design? And then we'll expand into how it all works.
Yeah. So the company Mediumation, they are a 4D company, 4D cinema company, and they work with cinemas throughout the world to update one of their theaters to make it 4D, so more realistic, having the movements, the smell, the touch, the feels of the movie come to life for the viewer. And the engineering that they do with that is amazing on its own, being able to track, like you said, a whole movie and understand this is what this needs to do, this is what needs to be felt, this is what needs to be smelt. That whole engineering is amazing on its own. What we ended up doing though, as for Festo, and how we partnered with them, was that they were already doing the movements before. So they were just using kind of standard uh, air solenoid valves and air cylinders to move it up and down. Um, and then when we partnered with them, they were already using our proportional valves to control the movements up and down already. It was a little bit more. I'm trying to say the right word. It was a little bit more rough draft, I would say.
Mm.
And then when we came in and we were saying, hey, we have this component, this motion terminal, this VTEM, that does servo pneumatics, the positioning essentially for you. We can help eliminate a lot of like the engineering that you guys are doing, and make it a lot more streamlined and easier for you. And so that's where we kind of moved into it to say, hey, this brand new terminal could be really good for you because this is going to do all the servo pneumatics. We can communicate back to your devices to make sure that we're able to, when your device says, "Hey, we need you to move up X amount," to make it seem like they're moving up in the movie. Our motion terminal will then move all the cylinders up, and then the rider can actually experience that. So that's kind of where we felt that we had the best partnership with them.
And so a
Um,
lot of this was the control portion of it, the control,
yeah,
which is what you were talking about earlier anyway,
Yep,
right?
exactly. So the motion terminal has a built-in PLC into it, so
Oh,
we're able to control. So the PLC, what it does is it's able to control all the movements for the ride, as well as control the smell. So say that you go through an area and it smells really strange, or you go through say in the movie you're going through a landfill. They can there's they've done a great job with their chemistry design of how different smells can be able to
wow.
create smells to make it smell like you're in a landfill. So our the PLC is able to control that to be able to turn on the smells, as well as they have these pokers. So they have these pokers in the seats to make you feel like you feel this little pinch or something like that as well. So all that's controlled with the PLC, and then the PLC is then communicating back to their higher level controller, which is essentially running the movie, and then that is telling the PLC what to do.
Right. And so the feedback is coming from the movie itself, or is that something that they're programming in separately? Um, somebody's watching the movie and programming it at the same time. And
It's the latter. So there's someone who actually goes through the movie, watches it, and then says, "Okay, this is what I should be experiencing, or this is what I should be smelling." So there is a gentleman there that does all of that, which I think is extremely hard, and a
yeah, I
lot
can
of
only imagine.
yeah, definitely a lot of uh, praise goes to him for making this come to life.
Yeah. And so over the years, has the components changed a little bit? You've updated them,
No,
was,
no, actually. So once we introduced the motion terminal, which was about in 2018, 2019,
wow.
it really hasn't changed at all. None of the components have changed, which kind of just shows the testament of how robust the motion terminal has been. There's been some software changes, obviously, as times as we move on and new
Mhm.
updates come out, but hardware wise, everything has pretty much stayed the same.
Well, and the software is done through apps. Is that right?
That's correct. Yeah. So for the motion terminal, there are several apps on there that you can kind of download into the Valve terminal, and each app correlates with a different function for pneumatics. So one app can be for a directional control valve app, one app can be for proportional regulation, one app could be for flow. They actually use a positioning app, which is essentially servo pneumatics. So they use that app to be able to move it up and down.
Oh, pretty cool. And then you said you work across different industries, and so this device is also used in other industries as well?
Yeah, it's definitely used in a lot of different industries. We find it a lot actually in research and development companies. So that's a huge win for us because what happens is that in these R&D labs, they're trying to test so many different things and have so many different ideas. So the how we introduce it into the R&D labs is saying, hey, we have this valve manifold that can do everything you want to do in this small frame. So that way you don't need to find it out on your shop floor like, oh, we need to go find a proportional regulator, we need to figure out how to plumb it into the system and stuff like that, or we need to get these flow control valves and put it into the machine to see how that works. They can just do everything from the motion terminal side and test everything to make sure everything's working. And then from there, they decide, okay, well, do we want to go with the motion terminal or do we want to use other components, but we know that it's working. So again, great for the research and development in that part of it.
Yeah. And so when they're doing all this research and everything, this is for multiple different industries you're talking about?
Yeah, it
So it
can.
just depends.
Yeah, it depend it could be for any industry. We've seen it happen in medical, in the life science to see if it works there. Semiconductors, in the semi field, that we'll see them test a lot of how to do like wafer holding or wafer
Oh,
cleaning,
yes.
that kind of stuff. We do a lot of testing with the motion terminal, and then they decide, okay, well, let's use. We know that it works. We know the proportional pressure regulator works. Let's see if we need want to use a different proportional regulator, but we know that it works with the motion terminal. In automotive industries, we see it a lot there, too. So yeah, all different industries. Honestly, in any industry, you can find a place for the motion terminal.
And then do you ever have to create a new app software wise for the different industries, or is it pretty much you've covered everything with the apps that you have?
I would say about 95% of all applications can be covered with the apps that we have. Um, very special, very special cases. We'll design a custom app. But again, that really just depends upon what the application is and if it's possible for us to do.
Yeah. And so what else do you do with Festo in general, besides just that? You design other components with them?
So for me, being a mechatronics applications engineer, I work a lot in the pre-sale and the post-sale stuff. So essentially, kind of more of like a consulting role. We have a sales team who obviously is first of line, make the first contact with the customer, talks with them to see if there's a project for them, and then once the customer says, "Hey, we do have this idea for something," then they'll bring me in. And then I'll come in there to speak with the engineers, to the design team, and they say exactly what they're trying to achieve. And then I'll then consult with them to say, hey, okay, from what it sounds like you're trying to do, I think that with our Festo products, I think that you can use this, and this to then be able to achieve what you're trying to do. So that's kind of on the pre-sale side of things. And then on the post-sale side of things, obviously afterwards, once they purchase it and they get everything there, then I can start doing training, commissioning, so to make sure that the engineers are feeling comfortable when they get the product.
Right.
So that's kind of where start to finish is where what my title entails.
Yeah. Oh, that's pretty cool. And we talk about mechatronics, just to back up a little bit, we're talking primarily electronics, or is it primarily mechanical,
Yeah.
right?
Yeah, exactly. So prior to so I've been with the company for 9 years, and I started actually as a general applications engineer, which if everyone doesn't know, Festo has over 50,000 different products. So I was covering everything from pneumatics to electric automation to process automation. So we offer a whole range of different products. And as a general applications engineer, I was able to touch on all of them. As a mechatronics engineer now, I'm focusing majority on electric automation. There's been a big push right now in our industry for electric automation over pneumatics because of the easeability of getting electricity now versus using compressed air,
Right.
as well as the cost of electric drives coming down. So now when we're talking with engineers, it used to be maybe like 10, 15 years ago, pneumatics was it was cheaper, it was easier, compressed air. The cost of maintaining it wasn't too bad. But now with electric automation, there's a lot more flexibility, and the kind of the features are starting to outweigh the cost. But even the cost is it's coming down a lot, where it's being very comparable to pneumatics.
And so do you see that the pneumatic valve that you're using right now for mediumation could eventually be all electric? Um,
So
and would it be more, I guess, would it be more accurate or about the same? And how do those things fit in? Yeah.
yeah, that's a great question. It's a
Sorry.
great question. So yes and no, actually. So I think that there is a time and place for electric and pneumatics. Um, with pneumatics, with air being it very compressible, it doesn't feel as
Severe?
severe. Yeah.
Oh,
So like because it's very precise and these movements can be very fast. And so imagine being in a chair and it just shooting up and down and there's no compressibility on it.
yeah.
So again, there's a time and place. So I think with it they're gonna stick with air for the cinemas. The only drawback though is the air, the noise of the exhaust.
Uh,
That's the biggest drawback that we get.
mm,
Um, because as you hear the air coming out, they need to be able to deafen that noise so that way it
right.
doesn't interrupt the movies.
That's right.
So that's that. But then again, we do have an application, or we had projects where they wanted to do electric actuators because, again, sometimes when you want to get into an area, there's no compressed air. So think of these, not amusement parks, but these barcades, kind of like a Dave and Buster's or stuff like that, where there's no compressed air in there, but they want to have a ride, like essentially a simulator ride in there.
Mhm.
That was one of the projects that we had talked about using electric actuators for.
But they wouldn't probably do as wide a variety of movements as well, because because they do have that hard stop.
Exactly. Yeah. So we would have to really, really tune the motors to make sure that the accelerations are extremely low, but that also draws back the amount of reaction time too. So again, it's a very fine line, which is why we're still in the talks about possibly still trying to do electric actuators for those projects.
Well, it just depends on what the application is, like you said before. I mean, does it involve a human, doesn't it?
Yeah.
That,
Yeah.
that probably has a lot to do with
Yeah.
it. So, um, but this is great. And so I really appreciate your time here.
Mhm.
I think we covered, I tried to do this 10 or 15 minutes, and I think we covered most of what we wanted to cover. And I really appreciate um, engineering and the creativity that goes into it. And thank you.
Yeah, I appreciate it. Thank you again for your time, Terry.
Yep, absolutely. We'll talk to you soon.
Sounds good. Thank you.
Okay, bye.